So hello, good morning. Um, it's good to be here again. So we are taking off. We ended on some exercises on lines, and we are done with that. We want to continue with chapter 3, which is dimensioning. Okay. So basically, we are just going to look at some rules that has to do with dimensioning. Okay. So now these rules are going to be very useful when we start um, dimensioning any parts, or when we delve into tangency and orthographic projections. So you have to take these rules very, very carefully and apply them. Okay. So the first of these rules is okay. Hold on. So the first of these rules is that dimensioning is the expression of the size. Well, that's not the first rule, but as a form of an introduction, it's a dimension is the expression of the size and position of an object, okay, graphically with the help of numbers, lines, okay. So what we are doing in dimensioning is basically to size to size an object, okay, in terms of giving giving the particular um, I mean, not giving, but with the help of numbers, okay, lines, and then appropriate symbols. So dimension is the expression of the size and position of an object graphically with the help of numbers, lines, and symbols. Okay. So now that we've seen what the dimensioning is, we want to just dive quickly to look at these rules I mentioned earlier on. Now, the first one is that dimension lines are to be drawn while maintaining a gap of 10 millimeters from the object line. Okay, so here is our object. You can see here is our object. We can see our dimensioning line here. Okay, now what is up here? Excuse me. I'm trying to get my laser pointer. I'm struggling to do that. Okay, so what's happening here is that we have our object. This is our object. Okay, and then here's another object, and then we have our dimension line. Okay, but this rule is telling us that your dimension line should be 10 millimeters away. So between this line and then the object's line, okay, that we are trying to dimension, there should be a gap of 10 millimeters as indicated here. Okay, as you can see, all these other lines describing this object, right, like an inverted three steps, are also the dimension lines are 10 millimeters away from the particular object lines they are describing. Okay. Now the second rule says that you should not cross dimension lines, should not cross extension lines. Okay, so here is our dimension line, and this thin line here, okay, now the thin line, as you can see, is showing the extent of this length, the length I'm hovering my pointer over right here. Okay, so these two lines are showing the extent of the object. Okay, now here our dimension line spans across these two extent lines. Okay, now these two lines, like I said earlier on, are what we call the extension lines. Okay, so the dimension line, the arrows of the dimension line just make they just touch the extension lines. Okay, on my left here and on my right here. Okay, but you see, we over here we see the very opposite, where the dimension lines are crossing the extension lines. Our dimension line, you can see the arrow, it has cut the extension line. Okay, that is unacceptable. And number three, all the information should be written horizontally. All the information on the the object we are dimensioning should be written horizontally. Okay, so you cannot have a lettering that concerns the dimensioning. Here we have a horizontal one, and it is not allowed to have a vertical one. Okay, now the fourth rule of dimensioning: a given dimension should be indicated only once. It should not be repeated at another place. Okay, now so 15 here is the space between this line that I'm moving my mouse over and this other one. Okay, so, as we see soon in orthographic projections, they are just two different views, front view and side view, of the same object. So if we show this dimension here, okay, and this other one here, so this is the front view. We are describing the front view with some dimensions. When we come to the side view, we should not indicate the same dimensions again. Why? Why is this very important? So that you do not make your work cumbersome. Okay. Otherwise, the whole work, your whole orthographic projection, for example, is going to be, there are numbers going to be littered all over the place. And we do not want that. Remember, with a technical drawing, it's a language of communication. The clearer it is, the better. Is that okay? Okay. Now the seventh rule. The overall dimensions should be placed outside the smaller dimensions. Okay. So if you are dimensioning something with so there are smaller lengths, and then there are larger ones. It's always advisable to place the smaller lengths, like you are saying here, within the larger one, so that the idea is you don't want to have extension lines. See this extension line here? You see, we don't want to have extension lines crossing dimension lines. You remember one of the rules where we said that I think, oh, oops. Am I still sharing? Okay, so which one of them is that? Yes, rule number 2, where we said dimension lines should not cross extension lines. Okay, in fact, rule number 7 is just sort of overlaps with rule number 5. Okay, so is that same reason that, yes, it's for that reason where we do not want dimension lines to be crossing extension lines. that we are now saying that dimension line should be placed outside, okay, outside of smaller dimensions. So if you have a larger dimension, place it outside or over a smaller dimension. So this is wrong and this is correct. And then also when an overall dimension is given, one of the smaller dimensions should not be given unless it is needed for reference. Okay. Now, when you look at these two examples, we can easily deduce this other dimension here. Of course, is 30 minus 10 minus 10. So now, if it doesn't help us in any way if we should repeat this dimension. Okay, it just makes the whole work cumbersome. The next rule says that the larger dimensions should be placed outside the smaller ones, such that the extension lines do not cross the dimension lines. Okay, so this one too is just another version of stating rule number 5. Rule number 5 over here. Rule number 5. No, 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 no. Okay, rule number 5 over here. All right. So larger dimensions should be placed outside the smaller ones, such that the extension lines do not cross the dimension lines. Okay. The rule says that a given dimension should be indicated only once. No, we've done this. Yeah, here, we just finished it. Okay, so this is where we are. When an overall dimension is given, one of the smaller dimensions should not be given unless it is needed for reference. Okay, and I've already stated why. Larger dimensions should be placed outside smaller ones. Okay, that we've also covered. Now, no dimensions other than those that are necessary need be given. Okay. Now, if you look at this drawing closely, now this dimension here, 25, helps you to know the distance between this side of the object and the center. Okay, and the center of this hole here. All right. Now the 50th dimension again shows how far the two holes are apart. Okay. Now there's a third dimension where you've been given the distance between one end of the plate and then the other end of the plate. Okay. Now, so this 25 millimeters dimension is actually, if you put it there, it does not serve any need. It does not help whoever is drawing in any way. So we want to avoid that. Next one. So in fact, this slide here is an explanation. We've seen this already, but it's an explanation of is an example of a case where we do not want to repeat dimensions that we do not need. So this title block here could have been easily been drawn, even without knowing the dimension, the length of this side of the title block, this length indicated here, that the brown arrow is pointing at. Okay, so what you are doing is essentially you are taking measurements from this side of your borderline till you move. When you get here, you go to the other side, because we already know that the length of the title block is 185 millimeters. So we know the end. So we start measuring from the end, and then start measuring from the left towards the right. Okay. Then we actually do not need this dimension. All right. So this is what the slide I'm showing you right now is an explanation of the previous rule. Okay. Now the next rule says that avoid indicating dimensions inside of a drawing. We'd like to have our dimensions outside than to have it inside. Okay. For this, again, for the same reasons of we don't want dimension lines to cross and want to have a neat drawing. Now, also, we want to always indicate the diameter of a circle, not its radius. The symbol phi is used before the dimension, except when it is obvious. Okay, so we use radii when we are describing arcs, but when we are describing holes or circles, we use diameters. Okay, diameters, and the symbol is phi. Okay, so you can see clearly. Now, in this projection we are seeing here, in this projection, over here, we have circles as well. Now, it is wrong to indicate the radius of the circle. The right thing is to indicate the diameter of the circle. Okay. So over here we have radii. Enters rule 11. It says that the radius of an arc should always be indicated with the abbreviation of r placed before the dimension. So like I said, for arcs we indicate radius. Okay. And like we had phi for indicating the diameter of holes. For the radius of arcs, we have r. Take note of that. Okay. Now, by this time, I'm sure many of you have questions. You just have to comment below this video whatever questions you have, or you ask for clarification when we meet for our tutorial. Okay. Now, rule 12 says that extension lines should not cross each other. Okay, or dimension lines. Okay, so extension lines never cross dimension lines. Extension lines never cross other extension lines, unless this can be done without making the drawing more complicated. Okay, so we prefer to have this than to have this. Okay, we can see our extension line crossing over here where I'm hovering my mouse. Extension line is crossing. This extension line is describing the dimension, this 10, from this line over here, to this line over here. Okay, and this other 10 here is giving the dimension between this line and this other line. Okay, we can see it's crossing, and we want to avoid that in every drawing you produce. Okay, 13, avoid dimensioning of hidden lines if possible. Hidden lines should never be dimensioned. Now, if you are viewing this block from behind, you're viewing this block from this side, viewing this block from the side where I'm, if you can see my mouse. Okay, viewing from there, you do not have to show this. Now, when you are viewing from here, all this side and this side will show as hidden lines. That is what we have here. Okay, and if you have such a thing, you do not indicate it. All right, in this case, we are, again, let me mention, we are viewing the block, the stepped block, from the left. Okay, so this is actually the left end view, and we do is there something wrong here? Okay, so we have viewing from the left hand view. That is why the hidden lines are showing. But instead of placing the dimension on, instead of letting the dimension describe the hidden lines, it's preferable to have the dimension being described where we do not have a hidden line. So this line is an outline, it's not a hidden line. And then this other one, we are putting a dimension there. You see? So it's incorrect if you place your dimension line in such a way that is describing or is connecting to a hidden line. That's what you want to avoid. Then there's also always potency that always show the angles outside the space representing an object. Okay, so we have the angle, we have this 45-degree angle outside. This angle is describing here. Okay, it's describing this. I think I can write that. So it's so obvious. This angle 45 is describing this and this. Okay. All right. So instead of having that angle here, 45. Okay. Forgive me. My pen is too large. So it's 45 degrees. Instead of having that inside the object, we prefer to have that angle outside of the object. Very, 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 very important. Okay. Number 14. So number 14, that was number 14. Number 15 says that center lines says that center lines should never be used as a dimension line. See that center line should never be used as a dimension line. So over here we have our center line. The same thing here. Okay. Now this rule is telling us that we should not, it's telling us to not draw our dimension line using the centers. Okay, of course, the dimension line is describing how far the centers are from each other. Okay, but we do not put our dimension lines on the centers. Okay, rather the right thing is to draw an extension line and two extension lines. Okay, this one over here and then this one. So our two extension lines indicating the centers of the two holes. So this one is incorrect. This one on my right is incorrect. This one is the correct one. All right. 16, dimensions should be given from the center lines, finished surfaces or datums. Now, datums is just a reference. Datum is just a reference point. Okay, we are saying that okay, so when we are giving dimension lines, it should start, our extension line should start from either center lines, finished surfaces, or reference datums as applicable to the drawing. That is what we are seeing here. Okay, so over here in the lower drawing, we are having the left side of the block as let's call it a datum. All right, and then the center of this hole is 30, is being indicated here, is 30 millimeters from this datum. Okay, and this center hole is 60 millimeters from the datum, and then this last one is 90 millimeters from the datum. Okay. Now, at this point, I want to mention that there are two systems of dimensioning. Okay. Now, there is a unidirectional system. Okay. Now, in the unidirectional system, your lettering or the numbers that describe the size of whatever dimension you are showing, remember the lettering, they should flow in the same direction. Okay, so here we have our 20 going in the horizontal, and then our 15 also in the horizontal direction. Okay. So all dimensions must be upright and readable when the drawing is viewed in its normal upright position. Okay, so there was a unidirectional, and then there's another example of the unidirectional. So you see the direction of this line is now inclined, but you notice that all our dimensions, radius, this is wrong. The diameter should have been indicated. The diameter of these two holes should have been indicated, not the radius. Sorry for that. Okay, but you can see clearly that all the dimensions are in the horizontal direction. All the direction are written in that way. Okay. Okay. So it's wrong to attempt to do something like this. It will be wrong if you attempt to do something like this. Okay, so that is wrong. Very important. Okay. My laser pointer. Okay, back. Now there is then also we have what we call the aligned system. Aligned system. We looked at the unidirectional system previous two slides. Now we are looking at the aligned system. In the aligned system, the dimensions must be readable when the drawing is viewed in its normal upright position or from its right hand side. What that is saying essentially is that if we should rotate this drawing, this way. Okay, if you rotate this drawing clockwise, okay, we should be able to read the dimensions. Now, if it's also kept, if it's without the rotation, we should also be still able to read our dimensions. Okay, so with or without rotation, we should be able to read the dimensions. Okay. Now, so this dimensioning system makes room for rotating your drawing sheet or rotating your drawing space. Is that okay? Okay. So let's compare both systems of dimensioning, unidirectional and then the aligned method of dimensioning. All right. So one of them in the aligned system, look at the aligned system carefully. We have, so this is allowed for aligned, but let's look at this one first. Here we have the 30. The dimension line is horizontal and the 30 is horizontal. Now, when the dimension line changes that direction, so now the dimension line is vertical. Okay, our dimension line here is vertical, but still the lettering is still in the horizontal. We come here, the converse is happening. That is why this one is wrong. That is why this one is wrong. Now, in the aligned system, remember, the lettering always aligns itself with the direction of the dimension. I'll take that again. The lettering always flows along the line of the dimension, or it is always aligned to whatever direction the dimension line is moving in. Okay. Now, so this in the align system, we should have our 30 aligning itself with our directional line. So this is essentially the same as this. Okay, so these two are correct. Forgive me again. This shouldn't be here, but this one is wrong because the 30 is at the movement of the writing of the 30 is perpendicular to the dimension line. Okay. 19. In a drawing of a part with circular ends, center to center dimension is given instead of an overall dimension. What's an example of an overall direction? An example of an overall direction is an example of an overall dimension is the distance from here. Let me draw an extension line here. Oops. My extension line is supposed to touch the object. Okay, so my extension line again. All right. So instead of having this, instead of having my dimension line is crooked because I'm using my hand. Okay, so instead of having a dimension like this, instead of having a dimension like that, we are having a dimension from the center of the holes. Okay, so it's wrong to do this. What I've done in red is wrong, but the right thing is to have the dimensions from the center to center of the holes. Okay, dimensions center to center of the holes, very important. Okay, next, when the number of dimensions are indicated on one side of a drawing, they should appear on a continuous line. Okay, so now all these dimensions over here are at the bottom part of the drawing which is being shown. Okay, all these dimensions 10, 20, 15, they are showing at the bottom part of this stepped rod or a stepped shaft or a stepped cylinder. Okay, now since the numberings are at the bottom part, okay, now because they are at the same side, the dimensions should be in line. The dimensions should be in line. Okay, so 15, the dimension line for 15 is coinciding with the dimension line for 20, this 20, and it's coinciding with the dimension line 35. But the converse is happening here. All the numberings are at the bottom side of the shaft, but they are not coinciding. 15 is somewhere else. This one is also somewhere else. Okay, it's more like, it's almost like Mario jumping steps or Mario jumping pipes. Okay, but the right thing is for the dimension lines to be coinciding. Okay, intersecting construction lines, and remember construction lines, faint temporary lines used in drawing, faint, and they are easy to erase when we don't need them. Now, intersecting construction lines and projection lines shall extend slightly beyond their point of intersection. All right. Now, this construction line, or this is intersection line, is there for the purpose of dimensioning. You remember we said in one of our points that dimension should not be inside the object. So we should not have our dimension over here, but rather we should have our dimension outside of the object. The dimensions are the right place. Okay, and to indicate that dimension, you draw intersecting lines outside of the object. Okay, and it should be beyond the point of intersection. Here's our point of intersection. Look, my laser pointer is showing it.